Hello, students. In this video lecture, we'll be learning about the next type of clustering, that is density-based clustering. So this is a type of an unsupervised learning technique. So where the objects are clustered based upon the density of data points. Okay, so this dense can also be called as mass or volume. Okay, so where the dense regions will be separated from the sparse region. So for this, we have the algorithm that is called as dbSCAN. The full form for dbSCAN is density-based spatial clustering for application with noisy data. So this is an algorithm where the user does not require to give the number of clusters as an input. And this can also make clusters of an arbitrary shape. So this also handles data with noisy input. So generally speaking, this density-based clustering, it has two inputs. The first one, it is epsilon, and the other one is minimum number of points. So epsilon, it is the radius of the circle formed with the data object as the center. Okay, so say for example, in this diagrammatic representation, so from considering A as the center, okay, and epsilon as the radius, okay, you are forming a circle by considering some data object as the center. And the minimum number of points is the number of data points that lies within this radius. So if you consider within this epsilon 1, 2, and 3, three data objects are available within this radius of the circle. So now, depending upon the way how these points are available, generally there are three different classification of data points. The first one is core point. So core point is the one that should be able to satisfy the condition of the minimum point. So like how many number of points should be available within that radius of a circle. So say, for example, if we have given the minimum number of points as 4, so in case within a particular region, if there are 4 data points, then that can be classified as a core point. So, and boundary point is the neighbor of the core. Okay, so, and if you consider this as an example, if you have, let us assume that the minimum number of points that you consider as 3. Okay, so from P as a center, this is the circle that is formed. And from R as a center, this is the circle that is formed. So in that case, if the minimum number of points, let us assume, for example, it is 3. So 1, 2, 3. There are 3 data points within this radius. So P is a core point. So similarly, if you consider R, 1, 2, and 3, there are 3 data objects within this boundary. So therefore, R as a core point. So, but if you consider the data point Q and S, they are called as what? Boundary point, because we see that it is having one of the point, that is core point, as its neighbor. If you consider Q, and though it does not have any minimum number of points within this radius, but however, it is having P as its neighbor, where P is a core point. So therefore, Q is a boundary point, and we see that T is identified as a noisy point because it is quite deviating from every other data point. So this is how you need to classify the data points. So now coming on to the example that let us consider for this density-based clustering. So let us assume that you have for any point, you have X and Y dimension. Okay, so and which is represented in this form of an input, and the same if it is represented in a form of a two-dimensional plane. So we see that there are a few clusters where the dense data points, the objects that are very close to each other, it is in one cluster, and the sparse, and which is in different cluster. So, and we see that these are all the outliers, which is neither a core point nor a boundary point. So with this example, let us assume that we choose the value of epsilon as 0.6 and the minimum number of points is equal to 4. Okay. So let us consider the first data point and calculate its distance from the other data point. So in this data set, the first data point is 1, 2. Okay. So 1, 2, and when you calculate the distance with the help of the Euclidean distance measure with every other data point. So when you calculate the distance between an object to itself, so 1, 2, this is also 0. And calculating the distance between 1, 2 to 3, 4, it is 2.8. Okay, so that is square root of 1 minus 3 the whole square plus 2 minus 4 the whole square. We get the answer as 2.8. So similarly, between 1, 2 and 2.5, 4, the distance is 2.5. So in the same way, from a given point, you will have to calculate the distance to every other point in the input data set. So the distance is calculated and it is added up in this given table. So now in this problem, the epsilon value, it is given as 0.6. So you will have to take each and every value of distance and those value whose distance is less than 0.6. Okay, so those are all the closest neighbor. Okay, so when you assume here, so only these 2 points, which is having 0.53, which is less than 0.6, 0.5, which is less than 0.6. So we see that, so for this given input data set, the two closest neighbor is 1.2, 2.5. This is one of the neighbor. And the second neighbor is 1, 2.5. Okay. So now the same way, you will have to repeat the process for every point in the data set. So how we have done for this given input point, and then we have calculated the distance with respect to all the point of the input data set. In the same way, you will have to repeat the process. Okay, so from the next point, okay, so I'm calculating the distance to the other point. Okay, so this process remains continued. So let us assume that after doing this calculation based upon the epsilon value, that is 0.6. So let us imagine for the point 1, 2, there are two neighborhood points, that is 1.2, 2.5 and 1, 2.5. So, and for the next data point, let us assume that these two are the data point. For a given point, these 3 points are the neighborhood point. So now, in the same way, you will have to complete the process for all the points of the input data set. And then we will have to classify which one is a core data point and which one is a border point and which one is an outlier. So core data point, already you know that. So those points which is having the minimum number of at least the minimum number of point should be the condition whatever that is given here. Okay, so the minimum number of points here is 4. Okay, so in that case, if you consider this point, it is not having 2 points as neighbor, it is only having only 2. So for this also, it is only having 2. But if you consider this point, 1, 2, 3, 4, so this is a core point which is having at least the minimum number of points. So this is identified as the first cluster. And if you consider this data point, 1, 2, 3, 4, okay, it is having at least the minimum number of points 4. So this is identified as the second cluster. And if you consider this data point, it is having at least 1, 2, 3, 4. Okay, so with this given input data set, the number of clusters that are identified is 3 clusters. Okay, so now considering the property, okay, so you see that 1.2, 2.5, this is core, 2.8, 4.5 is core, and 1, 2.5 is core. So now the same, I have written it here even. So 1.2, 2.5, it is a core point. So now What about this data point 1, 2? If you consider this data point, it is having at least one of the point as a core point. So 1.2, 2.5, this is classified as a core point. So though it is not having the minimum number of data points that need to be satisfied, but at least one is a core point. So meaning that this is very close at this point is closer to the core point. But however, it doesn't have the minimum number of points as the neighbor. So therefore, this data point is identified as what? The border point. The same way, if you consider the next point, that is 3, 4. Okay, so 3, 4, the neighbors are 2.5, 4, 2.8, 4.5. So here we see that the 2.8, 4.5, this is a core point. So we see that at least one is identified as a core. Therefore, this point is a border point. Okay, so this point is a border point. So now coming on to the next one. So similarly, if you consider 1.5, 2.5. So we see that it is having 1.2, 2.5. This is a core point, which we have already identified as a core point. So therefore, it is having one of the neighbor as a core point. So therefore, this point should be classified as a border point. So the remaining, whatever we are not able to classify either a core, okay, nor the border point, okay, so neither core nor border point, that is classified as an outlier. That is classified as an outlier. So with this, you would have understood about the concept of what is density-based clustering. Okay, so thank you all. We will see in the next lecture.